Okay, in this short video, we're going to talk a little bit about congruent triangles. Congruent triangles are triangles that have both the same shape and the same size. So if triangles have the same shape, that means they have identical angles. So congruent triangles will have corresponding pairs of matching angles. So for example, 35 and 35, 70 and 70, 75 and 75. So they have the same shape. Congruent triangles also need to be the same size. So corresponding sides also need to be equal. 10 equals 10, 16 equals 16, and 16.8 equals 16.8. So these two triangles are congruent. They have the identical angles, identical sides. Therefore, they're the same shape and the same size. One thing we've been doing in class is writing congruency statements. When we name triangles, we name them after their angles. We use capital letters to indicate angles. So we have triangle ABC. And if we want to say it's congruent, we use the equal sign with a tilde. That little squiggly line on top is called a tilde. So we say is congruent to this other triangle. And when we name the other triangle, we've got to make sure that our angles are corresponding. So what angle corresponds to angle A? Well, angle A is 70, so it corresponds to X. So I want to put the letters in the same order. Next is B. B is angle 75. That corresponds to Z. And then, of course, Y corresponds to C. So this is another way of saying triangle ABC is congruent to triangle XZY, because I could see that all three angles and all three sides are equal. Now, we don't necessarily need to know all three sides and all three angles to prove or to show that triangles are congruent. So for example, might be a little bit hard to see. I'll try to zoom out with my camera a little bit. Whoops, can't go too high. But what I've got, and I'll try to show it on the desk here, is I've got three pieces of paper of different lengths. So I know all three sides. I've got side lengths. I can only assemble one triangle out of these three sides. So for these sides connected in a triangle, there's only one shape that I can make. And I know it's not exactly zooming correctly, but any three three sticks of different lengths can only make a triangle of one shape. I could rotate it, but it's still the same triangle. It still has the same angles. So if I know that all three sides are equal in two triangles, even if I don't know any angles, the measure of any of the angles, I can prove congruency. So we call that a side-side-side proof. So if I know all three sides are equal, so let's look at an example here. So I'm saying this is a scalene triangle, all three sides are different, but if I have another scalene triangle here, so side with one tick is the same as side length with one tick here, all three sides are matching. So by SSS, I know these triangles must be congruent. So if I label the first triangle A, B, C, if let's label this one PQR, often in math the convention is to use consecutive letters, I can prove that these triangles are congruent because I can show that the three sides are equal. So AB is the same as PQ. We know that A corresponds to P. A is between the 1 and the 3. P is also between the 1 and the 3. So AB is the same as PQ. BC is the same as QR. They have the same length. I use two ticks to indicate that. And then RP is the same as CA. And maybe I should have put those in a different order. But I'm showing that all three sides are equal in the corresponding triangles. And therefore, by SSS, we know that triangle ABC is congruent with triangle PQR. And again, we want to make sure that we name the triangle so my angles are corresponding. Angle C in the first triangle corresponds with angle R in the second triangle, and so on. So that's one type of congruency proof. If I know that all three sides are equal, I can show that. I can show all three sides are equal, and then say that by side, 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 I know that the triangles are congruent. But there are a couple other ways that I could also prove congruency. So I'll go back to my triangles. If I know two sides of a triangle, so I know the length of these two pieces of paper, and I also know the angle between those two sides, there's only one way, and you can see pretty clearly, there's only one way to finish this triangle. So if I know a side, the angle in between, and then the other side, that's also enough to prove congruency. Because I can only make one unique triangle, one shape of triangle, if I have the two sides and the angle in between. So one way that we could write that is side, angle, side. So if I know the angle between two sides that lengths I know, I can also prove congruency. So let's look at an example. Maybe we can use some numbers this time. If I've got 8 centimeters, 9 centimeters, and maybe this is 32 degrees. And if I have another triangle that is also 8 centimeters, 9 centimeters, and 32 degrees, because side, angle, side corresponds with side, angle, side, I know that these triangles must be congruent. And so the way I could write my formal proof, we can again name them. Let's use some different consecutive letters. D, E, F, G, H, I. Well, I know that side EF corresponds or is equal to side GI. So that's the 9 centimeter side starting from the 32 degree angle. So they're corresponding sides. EF equals GI. And I also know that angle E, so I'm saying the measure of angle E is of course measured at angle G. They're the same angle, 32 degrees. And I also know that on the other side of that angle, I know that ED, which is 8 centimeters starting from the 32 degree angle, must correspond and is equal to GH. So I know side, the angle in between, and then another side. And so I can say that therefore by SAS, that is also enough for me to prove or to show that triangle EFD is congruent to triangle GIH. So I can pick the order I want to put the letters of the first triangle. So I could call this DEF, FED, they're all correct. But once I've named the first triangle, there's only one way to write my congruency statement because my angles all need to correspond. So angle F in the end is equal to angle I. We don't know what it is yet. In our trigonometry unit, we'll learn that. But whatever angle F is, if we just call it check mark, that's going to turn out to be the same as angle I. And then, of course, also, whatever angle D is will be the same as angle H. So we can also prove the triangles are congruent as long as we have this two sides and the angle in between. There's one third way to prove congruency. If I just know one side of a triangle, so there's one side of a triangle, I'll try to show it on my paper, and if I know the two angles surrounding that side, so let's say I don't know the lengths of this pink side, but I do know the angle in between, and again, it's leaving the page, so let's say it's going on, we don't know how long it is, but I do know the angle. Well, it's pretty clear that these two sides are going to meet at a certain angle. There's only one way for those two sides to meet. So if I know angle, side, angle, that's also enough for me to say, well, there's only one triangle I could make. So if two triangles share angle, side, angle, they also must be congruent. So my third type of congruency proof is angle, side, angle. So let's just do one example, one proof like that. So we'll draw maybe a triangle with a different shape. So I don't know, we could estimate that. It looks like an acute angle, maybe 50 degrees. I don't know, maybe that looks like it's hard to estimate. Maybe that's 2.4 centimeters. That looks obtuse. Maybe it's 110 degrees. Then if I draw my other triangle, again, it doesn't matter how it's rotated. But if I draw another triangle, it's hard for me to draw a congruent triangle. I don't have a ruler. Again, nothing in this unit is necessarily drawn to scale. But if I have 110 degrees, and then if we call that 50 degrees, and this is 2.4 centimeters. So again, it's not necessarily to scale, but it's pretty clear here that I've got angle, side, angle corresponding with angle, side, angle. And that's enough to prove congruency. These triangles must be the same size and the same shape. We know obviously they share the third angle, has to be 20 degrees by ASTT, and the two side lengths must also therefore be equal. So how can I prove that? Let's just name this one. Let's say LMN. Call this one ABC. So I want to show that angle, side, angle in that order are equal to each other in the corresponding triangles. So angle L is the same as angle C. And then that side length L to M must correspond. So L to M is between the 50 and the 110, so that corresponds to CB. We write the side lengths using the two angles on either side of it, the 2 points on the ends of the line segment. And then angle M, which is 110, is equivalent to angle B. So I've said I've got angles are equal, side, and then the next angle. So I can say, therefore, these are the facts that I observe, and therefore I can conclude that by angle, side, angle, triangle LMN must be congruent, the same shape and the same size as triangle. And I want to be careful that I name it correctly. So L corresponds with C, M corresponds with B, and of course N must then correspond with A. So there's my congruency statements. These are called formal congruency proofs. There's 3 types of these proofs. I either need side, 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 or angle, side, angle. So that's how we write our congruency proofs and how that we can formally show that 2 triangles are congruent. Thanks for watching. Send me an email if you have any questions. And in our next video, we will discuss triangles that are similar, triangles of the same shape, but not necessarily the same size. Okay, that's all for now.